This session is regarding the exception handling in the Python. What is meant by an exception? An exception is an event that occurs during the execution of the program, and this exception interrupts the normal flow of the program execution. This exception, we can handle this exception handling in the Python by using the try, catch, and the except keywords. When a Python script raises an exception, it must handle the exception, otherwise the program will terminate automatically. This is the basic exception hierarchy in the Python. The base class of all the exceptions, it is the base exception class, and the exception class, it is the child class of the base exception. The runtime errors and the syntax errors comes under the exception class. These are all the runtime class, and the syntax errors, those come under the exception class. And how can we handle the exception in the Python? We can handle the exception in the Python by using the try, catch, try, except, and the try, except blocks. This is the syntax what I have given in the, this is the syntax in the Python script. We can handle the exception handling in Python by using the try and the except blocks. The try block, the statements, the that comes that raises the exception, we have to put those statements in the try block, and this except block, it handles the exception. This is the try block. After that, this try and except, these are the keywords in the Python script, and after the try we have to put the colon, and the statements inside the try block, it follows the indent. This is the syntax what we have shown here. This is the, and except, when an exception rises, the except block executes. See, in this particular one, try, except, and this we can write as many excepts as we can. So see, this is for the first one, except exception 1, except exception 2. And these are the important points for the try and the except classes. A single try statement can have the multiple except statements. After the except class, we can put the, see, this is the last one, else class. Else class means if there is no exceptions in our program, then after the try block, then directly control comes to this else block. And this is the example for this one. And in this example, I didn't use any try except block. See, the first statement is amount, it is a variable, and the one most important thing in the Python is we no need to declare the variable. There is no particular data type in the Python. So I am directly initializing the amount equal to some 10,000, and A equal to C amount divided by 0. I am dividing some amount by 0. This type of program, the Python handles these type of programs like this. It throws the error, 0 division error, division by 0 error. This program is regarding the without the try except block. And see, this is the example I have used in the try and the except blocks. I have initialized A equal to 5 and B equal to 0. And see, this is not the integer 0. I have given it as the string, and I am printing A divided by B. In the except block, I have given print some error occurred, and this is, and this print statement, it is out of the except block, out of try except blocks. The output for this one is I am trying to divide a integer number by the non-integer number. So the except block has raised. So it executes the output is some error occurred. The control comes to the except part. After executing the except part, the control comes to the after the except block statements. So the output for this program is this one. And in this particular program, this is another example. In this example, instead of performing the division operation, I am performing the arithmetic operation addition. And see the main difference between these two programs. In the previous program, after the except one, I didn't declare any type, error type. In this particular program, in this program, but I am using the error, this type error. This is the, I am specifying the type of the error also. The compiler doesn't show any type of error if we specify if we specify the error or not. Here I am specifying a type error. Here I'm trying to perform addition on the integer and the string. In Python, this type of operations, the compiler don't accept this one. So it throws the error. Here in this except block, I have used the unsupported operation. I am printing unsupported operation, and outside the except block, I printed the out of the try except blocks. This print statement, it throws the error. So the except block has executed. And this is the example for multiple except blocks. I have used two types of except blocks. The first one is the type error and the second one is the zero division error. Here in this try block, I initialize a equal to 5, b equal to 0, and I am dividing 5 by 0. I am trying to print the result of this operation, 5 divided by 0. And this particular statement, it throws the zero division error. So the second except block has raised, and the output is division by 0 not allowed. And this last print statement, it is outside the try except block. So out of try except blocks. And except clause with no exceptions. If there are no exception in the particular program, then the else block of that particular try except else has executed. This is the syntax for this one. This is the try block, and next one, this is the except one, this is the except block, and see, this is the else block. If there is an exception, then except block has been executed. If there is no exception in the try block, then the control comes to the else block. If there is no exception, then this particular block has been executed. This is the example. See, I'm directly trying to perform arithmetic operation on the integer and the string. Here in this particular program, this particular operation throws the error. So I'm not using specify any type of error in the except block. So it executes the first one, except got exception. And instead of the test, I used an integer number 0. I'm trying to print arithmetic operation of the 1 and 0. There is no exceptions in this particular statement. The result is the 1. It is printing 1. See, this is the answer. The answer is 1. And this except block, it will not be executed because it doesn't throw any error. This is the correct statement. So the control comes to the else part. Print no exception, rise it. This is the output for this program. And if the particular program has multiple exceptions, then we can use the single except statement, exception 1 and exception 2, so on exception n. Instead of using multiple except blocks, we can use the same except statement. The example for this one is this one. In the single except block, we can specify n number of exceptions by, and we can divide these n number of exceptions by the comma operator. See here in this particular program, I have initialized d equal to 8 and I am trying to perform the operation, arithmetic operation on 8 and 5. And this 5 is not the integer number, this is the string number. And this one, it throws the type error. Type error means we cannot perform operation on two different data types, on the string and the integer. It throws the type error. In this particular program, I used two errors, two exception error classes. One, what they are called is the zero division error and the value error. See, in the except class, I have specified two types of error classes: zero division error and the value error. In the try block, what I am doing, a equal to, I am reading the number at the runtime, and this input statement, it is used to read the integers dynamically at the runtime. And this I am forcibly typecasting this particular value to the int, because this input, it returns the reading value as the string. The default written value of the input, it is the string. So we are typely forcing that value as the, converting that string value as the int. This is the type conversion. I am reading A and B values at the runtime, and I am printing this third statement. In this particular statement, I am trying to perform division operation. See, in this particular program, this is the result. The first numerator value I entered 100, and the denominator value as the 0. We cannot perform division by 0 operations. So the statement, it is the please enter valid integers. I put that particular statement in the except block. And next one is the finally class. You can use a finally block after the try block. The finally block executes whether an exception has raised or not. The except block has invoked only when the exceptions has invoked. The exception block executes. The finally block, it is nothing in that one. This is not the case. Whether your program throws an exception or not, the finally block must execute. The finally block must execute. And this is the example for the try, except, else, and the finally. If we put the finally block in our program, the finally block always executes. The main advantage of the finally block is to release the resources. In this program, the first I am trying to print try block, and the second statement and third statement I am trying to read the integers at the runtime x and y, and z equal to x by y. I am trying to perform the division operation, and here I have used the zero division error class in the except block. In the except block, I am printing two separate statements, and in the else block, I am printing else block and the division. See, and the finally, it always executes whether the exception has raised or not. The finally block always executes. The first one is I entered at the runtime. See, at the runtime we are taking two numbers. We are reading two numbers x and y. So enter a number 10, enter another number 5. What I am trying to do here is z equal to x by y, 10 by 5. There is no exception in this particular operation, 10 by 5. So in this one, the control comes to the else block. So print else block division equal to z. What is the value of z? 10 by 5, 2. So it prints just 1. And next, after the else block, we have to put the final block at the last of the try except else blocks. Print final block x equal to 0, y equal to 0. And the last statement is here out of try except else and finally blocks. And in the second example, I am giving the second number as the 0. See, in this particular statement, x equal to 10, y equal to 0, I have given those values. Z equal to 10 by 0. It throws the 0 division error. So the control comes to the except 0 division error. So the except block has been executed. Print except 0 division error block, and the next statement is division by 0 not accepted. Division by 0 not accepted. In this particular case, an exception has raised. In this case, the else block has not executed. The finally block executes. See this one, the finally block. The else block doesn't execute. The else block executes only when the exception has not raised in that particular program, and the finally is it always executes whether an exception has raised or not. The final block executes. And this is a how to raise an exceptions. And the raise, this is the keyword. We have to use this particular keyword to raise an exception. And see, this is the one. Raise, we have to print our statement, some particular string. And this is the example for the raise exception. Inside the try, and the important thing is we have to use the raise inside the try block. And the first statement here is, this is the one, x equal to int of input. I am reading one number and I'm forcibly converting the reading value as the int, x equal to some integer value. And I'm checking here, x is greater than 100. I'm checking whether the read number has greater than 100 or not. If it is not the case, I'm throwing one error, value error of x. The class name is the value error. Here in the except block, I am catching this one, value error. See this one, I have given the value 150. Here 150 is greater than 100. So it comes to the if block, rise of value error. So the class name is the exception name is the value error. So except of value error. 150 is out of allowed range. This is the message. And this is about the user defined exceptions. This up to now I have discussed about the predefined exceptions. In Python we can define our own exceptions also. We have to for that one we have to use the our own predefined user defined class. This is the one. See, in the try blocks, if number is less than 0, in the first statement is this one, number equal to I am reading a number at runtime and I am checking whether this number is less than 0 or not. If it is the case, raise invalid number error. This is not the predefined exception class. This is the user defined exception class. See, this is the one, class invalid number error of error. Error means this is the one. This is related to the this error. It is extends the exception, and this invalid number error extends the error class. In this one, I am sending one message. You have entered a negative number and the number value. Here, at this particular moment, this particular constructor has been invoked. Statement, you have entered a negative number. The statement consists of this one, and S consists of your entered value. Self dot statement equal to statement and self dot S equal to S. And in the except class, what happened here? Invalid number error as E dot statement means it prints this particular statement. E dot statement. What is this one? You have entered this message. I am saving it in the particular statement variable. So I am printing that one. These are the output, three different outputs for the program. In the first case, I have entered 100. If it is the case, this else part has been executed. If else, if number is less than 0, in this particular one, what is the value here? 100. 100 is less than 0, false. So it comes to the else part, in the square root of the number. I am finding the square root of that particular number. It is printing that message 10. And enter a number, minus 25. I have given minus 25. See, if number minus 25 is less than 0, condition 2, raise invalid error. So it comes to the accept invalid error as is. So it takes the statement, you have entered a negative number. This is the message. And the third case is 0. 0 is less than 0. The square root of the number is 0 itself. This is the end of the exception handling.